start from the problem of the traditional CPU-centric architecture. And for that, I brought a single example. You see 3 lines. In the bottom, you see the amount of GPUs being used, okay, from 1 up to 8 in this case, because this chassis holds up to 8 GPUs. In the next graph, you'll see 10, because our chassis can bear 10 of them. And the top one is just running a convolutional neural network that was trained to classify objects without any pre-processing pipeline. And you see that even when you run only the model, there's a diminishing return. You use the first GPU, you get 42 kilo frame per second. You use the second one, you get the same amount of performance. And it keeps going up to 4, but then start the diminishing return, you're losing the efficiency. So this is where you're starting to throw away cost and power consumption and not getting any return. Now, if you just add normalization to this pipeline on the pixel of the image, you drop, oh, by the way, so we were supposed to get to 336 kilo frame per second, and we got only 190. When we start to do minimum pre-processing, we're dropping to 140, and when we run the complete pipeline, we JPEG decoding, resizing of the image, normalization, and then the convolutional neural net, and all of it is offloaded to the GPU, we're wasting a lot of the capabilities. Now I'm going to show you what happens when you plug the same GPUs or other AI accelerators into our system. So the bottom line, the green one, is the 90K frame per second that we saw instead of the 336. When we take the AI100 from Qualcomm, a different inference device, we can scale up to 220. The capabilities of that device is 22K for a single GPU, and you see perfect linear scalability. You're not losing anything when you're scaling and adding more GPUs to your virtual private network. And then if you take the same L40S, the GPU from NVIDIA, you can even reach 420 kilo frame per second. So all this is feeding the total cost of ownership and the actual cost of the query of your deployed AI pipeline. And it's critical to increase the utilization of the GPUs and lower the system cost. These two contributors will give you better TCO from CapEx and OpEx. And I'll show you, these are the 3 modalities that you care about, the computer vision, audio, and natural language processing. And you see in all of them, we save up to 90% of the cost of the infrastructure you're using. So whether you're consuming a SaaS through a cloud, whether you own your own data centers, it's all coming to your bottom line. And if we zoom into another pipeline, this is automatic speech recognition. Starts from a coded audio. We decode the audio. We do some processing to reduce noise, and then we're running the speech recognition itself to generate the text. You can see that we can drop from this graph is actually putting in blue the capital expense. So this is using a 5-year amortization model of the cost of the server deployed in a data center for 5 years. And then you get to the CapEx investment that you need to make. And in purple, you see the operational expense, which is based on the power consumption and the average cost of energy across the US. And you can see that for this deployed pipeline, when you measure the cost of 1 million audio seconds that you're processing, you can drop from 43 cents to less than 5 cents. It's really changing our thinking and allow us to deploy more AI without thinking about the ROI, because we can now try more things and find the killer app that really increase the bottom line of our organization, of your organization.